Hello everyone, and welcome to my SP2 channel. In this video, we're going to be looking at a chemical nomenclatures, which means that the systematic naming for cations, right, for the anions, for the ionic compounds, as well as the binary molecular compounds. And we're going to have a practice at the end as well. Now, this lesson is a little bit heavier than our previous lessons, so everybody buckle up. We're gonna have a lot of fun together for the next few minutes, okay? Okay, so starting by the names for the cations. So here it says the cations formed from the metal ions, right? They are going to have the same name as the metal. There's no modification here. So for example, if I have Na, that will be sodium. But if I have Na plus, I'm just going to say sodium ion, right? Same thing for zinc ion or aluminum ion, right? Now, there are some other metals that they have multiple charges, right? It is possible to have different charges. In this case, we need to indicate the charge using Roman numeral and typically in parentheses following the metal's name. So for example, if you're looking at iron, right, that's Fe, so that's just iron. But if I have like Fe2 plus, then I need to say iron 2, right? If I have Fe3 plus, then I'm going to say iron 3 ion, right? I need to specify their charges using the Roman numeral. Same thing for copper. It could be like copper 1 or copper 2, right? Okay, and then I have another classes. This is the last one for the cations that form from the molecules composed of non-metal atoms. Okay, so we have to be careful here. For these cations, the name must be ending with this IUM. Okay, so examples, I have ammonium. So the IUM at the end of the name stands for the positive charge of ammonium. So ammonium ion, hydronium ion, right? So these are the examples that we have non-metal atoms such as nitrogen, such as oxygen. So we have to specify them using IUM at the end. Okay. Now, this page is all about the anions, right? Starting by monoatomic anions. So the names for monoatomic anions are formed by replacing the ending of the name of the element with IDE. For example, if I have just an H, that would be hydrogen. But if I have an H with a negative charge, I'm going to say hydride, right? Hydride, and then ion. So hydride ion. If I have only an oxygen, just an O, that will be oxygen. But if I have an O with two negative charge, right, I need to say oxide ion. Okay, now for the second one, we have polyatomic anions, right? And again, they're going to be also ending with the IDE. So some of these polyatomic ions or anions also have the same names, right? Ending with the IDE. So hydroxide ion, cyanide ion, right? Peroxide ion. Okay, cool. Now looking at the next page, we're going to continue here for the anions, and that is going to be for our oxyanions. Okay, so what do I mean by oxyanions? So these are polyatomic anions that are containing oxygen, and they are very common. They're pretty much everywhere, right? And that's why we try to kind of respect them. We have a specific name for them. We call them oxyanions, and we also have a specific naming, right? Kind of systematic naming for these oxyanions. Okay, so bear with me, okay, for the next few slides. Okay, so the ATE is used for the most common, which is also known as the representative oxyanion of that element. And then the ITE is used for an oxyanion that has the same charge, but one oxygen atom fewer. Okay, what do I mean by that? So looking at examples. So NO3 with a negative charge is the most common oxyanion of nitrogen, or let's say containing nitrogen. Okay, so nitrate would be the name, so nitrate ion. But if you look at NO2 with a negative charge, this one has one less oxygen atom, right? Let's say fewer oxygen atom. So I'm going to call that nitrite ion. The next example is for sulfur containing oxyanion. So the most common one is SO4, where we have two negative charge, which is known as sulfate, right? And then if I have one oxygen atom fewer, which is SO3 with two negative charge, I can call that sulfide ion. Okay. Okay, so we're going to continue here for the anions, and we are going to use prefixes for the series of oxyanions of an element that expands to four members. Okay, so listen up. The prefix per indicates one more oxygen atom than the oxyanion ending in ate, and hypo indicates one oxygen atom fewer than oxyanion ending in ite. Okay, so let me just summarize all of what I told you on this slide on this table here. Okay, and I want you to look at these elements in pairs. So look at the first two. You've got ClO with a negative charge and ClO3 with a negative charge, right? So I'm going to call the ClO3 as my chlorate. And because ClO4 has one more oxygen atom than chlorate, we're going to call that perchlorate. Okay, so you've got perchlorate and chlorate kind of together. Now for the other two, I have ClO2 with a negative charge and ClO with a negative charge. So the ClO2 would be chlorite. And now that I have one oxygen atom fewer than chlorite, I'm going to call that hypochlorite. So from the top to the bottom, perchlorate, we have four oxygen atoms. Chlorate, we have three oxygen atoms. Chlorite, we have two oxygen atoms, right? And the last one is hypochlorite, where we have only one oxygen. Okay, I hope that makes sense. So looking at the next page. Okay, so let's take a look at how we can name the ionic compounds, right? So now we have both the cations and the anions, and we'll try to like systematically name them. Okay, so here it says the names for the ionic compounds consist of the cation name followed by the anion name. So we always have the cation that comes first. So looking at the first example, I have calcium chloride. I know that calcium is my cation, so that must be the first name. And I also know that calcium belongs to the second column of the periodic table, and I don't have more than one option for the charge. So calcium must be always 2 plus, right? So I do not need to specify that. Then I have chlorine in a form of an anion, so that must be chloride, IDE at the end of the name. Okay, so calcium chloride, we're done. Looking at the second one, I have Al, which is aluminum. And again, I do not have more than one option for the charge. Aluminum must be always 3 plus. So you don't need to specify that. Just say aluminum. And then I have nitrate, which is my polyatomic anion, right? So nitrate, and that's it. Now for the last one, I have Cu, which is copper, but I know that copper has more than one possibilities for the charge. It could be copper 1, copper 2, right? So how do I know which one is here? When you're looking at your ClO4, which is your perchlorate, right? Perchlorate, we have negative charge, just one negative charge for that. But there are two for your perchlorate. So the overall negative charge is 2, so I need to have 2 positive charge to balance it out, right? And therefore, I can say copper, and then you specify the charge using the Roman numeral, which is 2, and then perchlorate. I hope that makes sense to you. Okay. So looking at this page, now we're going to be looking at the binary compounds. Okay, so what do I mean by binary? Binary means we have two elements, right? So these are the two-element molecular compounds. Now, the procedure that we are going to use for the naming of these compounds are going to be very similar to what we said for the naming of the ionic compounds, okay? So the name of the element farther to the left in the periodic table is usually written first. Now we have an exception, okay? The exception happens when the compound contains oxygen, chlorine, bromine, or iodine, pretty much any of these halogens except fluorine, in which oxygen is going to be written last, okay? So keep that in mind. If you have oxygen with any of these halogens, we need to write oxygen last. If both of the elements are in the same group, right, then the one that is closer to the bottom of the table is going to name first. Okay. Now, the name of the second element is given an IDE ending. Okay. And lastly, we need to use the Greek prefixes. I'm going to go over all of them in the table on the right side to indicate the number of the atoms of each element, with an exception that prefix mono is never going to be used for the first element. Okay, so looking at the table on the right side, if I have just one copy of that element, you can say mono. And remember, we're going to say mono only for the second element, not for the first one. Okay, if I have two copies, I'm going to say di, right? Tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, so these are the prefixes that we are going to be using them. And I'm just going to have an example for you. So looking at this table, we actually have three examples. So starting by the first one, Cl2, and then there's an oxygen. So I need to start by chlorine, and I have two copies. So I'm going to say dichlorine, and then there's only one oxygen. That would be mono, right? And then I have oxide. Now, because mono has an O at the end, right? And then the name of the oxygen is also oxide. So this one also has a valve. Then you can drop the A or even the O of the prefix, which is a lot easier to pronounce it. So you don't need to say monooxide. You can say monoxide, right? So dichlorine space monoxide. Looking at the second one, we have NF3. So I don't need to say mononitrogen, remember, because we're going to drop mono if you have it on the first element. So just nitrogen, and then a space. I have three of fluorine, so I need to say tri, and then fluoride. So nitrogen trifluoride. The last one is dinitrogen. Yeah, because we have two, right? Two of these nitrogens. And then I have tetroxide. And again, you don't need to say tetraoxide. You can say tetroxide. Okay. Cool, cool. So that brings us to the practice. So we're going to be looking at the names for these three ionic compounds. So starting by the first one, I see that I have K, which is potassium, and potassium is on the first group of the periodic table. That means the charge must be always +1. I don't have more than one option for that, so I do not need to specify that. So I'm just going to say potassium. And then the second part is going to be SO4, right? And that is my polyatomic anion, which is sulfate. So I'm going to say potassium sulfate. Okay, look at the next one. We have Ba, which is barium. And barium is on the second column or the second group of the periodic table. So that means the charge is going to be always +2. You don't need to specify that. I'm just going to say barium. And then I have OH, which is hydroxide. So barium hydroxide. Now for the last one, Fe is iron, but iron can have more than one charges, right? Like in terms of the possibilities, I have like iron 2, iron 3, so I need to specify that. So I need to look at my anion. That is Cl, which is chloride, and the charge for that is -1. And I have three of them. So to balance out the charge, I need to say iron 3 chloride. Okay, cool, cool. Okay, thank you so much for watching. If you found this video helpful, don't forget to give it a thumbs up, right? You can also share that with your friends, whoever is interested in this kind of stuff. If you're enjoying the content and you want to keep learning with me, you can hit that subscribe button. You can turn on your notification bell so you're not going to miss out any of our future videos. I always love to hear from you guys. Drop a comment below if you have any questions or if you have any specific topics that you'd like me to cover in our future videos, and I will definitely consider that. Your support means the whole world to me. Thank you so much. Take care of yourself, and I'll see you on the next video. Bye bye for now.